Okay. Bismillahirrahmanirrahim. We'll continue doing more problems. Let me see what will happen. Okay. This is all the exams problems. We'll continue doing these all the exams problems. Yeah, so we are here. I have n squared over 2n minus 1. Yeah. I want to check this. I want to find the limit as n goes to infinity of n squared over 2n minus 1 sine 1 over n. Yeah. If I let t equal 1 over n, then n is 1 over t. So you have limit t goes to 0. So n equal 1 over t. Huh? I have what? 1 over t square. Yeah. So the 1 over t square. Oh, let me do it this way. 1 over t times 1 over t sine t over 2 over t minus 1. This is a no. This goes to 0. So you have limit t goes to 0 of 1 over t over 2 over t minus 1 times limit t goes to 0 sine t over t. Okay. Now in this one, I have what? Infinity over infinity. So this is 1. So I get rid of this. So this one, use L'Hopital's rule. You have limit t goes to infinity, since it's the infinity over infinity, huh? For this one, I'm talking about this one. So you have minus 1 over t square over minus 2 over t square. And that gives me what? Limit as t goes to 0 of half, which is half. So this is the answer. Converges to half. Okay. In square, the same thing. Yeah. It will be the same idea, like this one. And the answer will be 1 over 3. I'll leave it for you. This sequence defined by this. Notice it's what? It's ln n square plus pi over e n square plus 1. I need to find the limit of an as n goes to infinity. Yeah. That give me what? Limit n goes to infinity of ln of this, where I can take the limit inside. Limit goes to infinity n square plus pi. I have the same degree. So this will be ln. This is what will be the limit 1 over e. This is the same degree. So take the coefficient, which is minus 1. So they're just minus 1. Okay. This one, yeah, I think we can do it by the squeeze theorem between minus 1 and 1. Actually, between 0 and 1. Yeah, it will be easier. Divide by 2 to the power n. So it's between 0 and 1 over 2 to the power n. I know that the limit of 1 over 2 to the power n is equal to 0. It will 1 over infinity, which is 0. So this is 0. So this is by the squeeze theorem, goes to 0. So it's convergence and its limit is 0. This one, I have two problems. First, I need to do this, which is L. He called it L. So I have limit n goes to infinity, n sine 1 over n. I can let t equal 1 over n. So I have what? Limit t goes to 0 sine t over t, which is 1. This is L. Now for the other one, for k, it will be the limit n goes to infinity of this. Yeah. I need to deal with this one. So this one give me what? Yeah, if I apply these things, I have infinity over infinity. So let me do L'Hopital's rule. I have what? E to the power n minus e minus n over 2 e to the power 2n. Okay. Yeah, now I need to take common factor. Since I have e to the power 2n, so take e to the power 2n common factor. You have what? E is minus n here. Minus e is minus 3n over 2e to the power 2n. This is cancelled. So limit goes to infinity, it will be 0 minus 0 over 2, which is 0. So this is k. So k is 0 and L is 1, so the answer is 1 for k plus 1, k plus L. Sequence defined by this, he wants A6. Be careful. You need to do the calculation. A3 is A2 minus A1, which is 1 minus 2, which is minus 1. A4 is A3 minus A2, which is minus 1, minus 1, which is minus 2. A5, it will be A4 minus A3. That is what? It's minus 2, minus minus 1, so it's minus 1. A6, it will be A5 minus A4. And that what is A5 is minus 1, minus minus 2. That will be minus 1 plus 2, which is 1. So be careful just with the calculation. Nothing to worry about. Okay, now this is going minus 1 to the power n times bn. Remember, we need to check only the limit of bn. That will be the limit of n cubed over n cubed plus 2n squared plus 1. This limit is 1. So if you remember, if you said if this limit not equal to 0, so then this sequence converge. So that means the limit does not exist, or the sequence diverges. If it is 0, then it will converge. If it is a value other than 0 or infinity minus infinity, then it will diverge. Yeah, this one we need to write the formula. It's a question about the formula. Yeah, be careful here. I have what in the numerator. I have 3, 4, 5, 6, 7. So it's very clear. It's starting from 1. I'm starting from 1, n greater than or equal to 1. So it will be n plus 2. But I have also a sign. I have 1 minus 1, 1 minus 1. Since I'm starting from 1, I have for 1 should be positive. So minus 1 to the power n minus 1 or n plus 1. Both will be correct. In the denominator, I have 5, 5 squared, 5 cubed, and so on. So it's 5 to the power n. So this is my answer. This sequence, sine to the power, sine 2n over this. Yeah, I think we can do it by squeeze theorem. Very clear. I divide by 1 over plus square root of n. Yeah, as n goes to this is goes to 0. This is goes to 0. So this is goes to 0 by the sandwich theorem or by the squeeze theorem. This sequence, same idea. I know cosine 2n is between minus 1 and 1. So cosine 2n over 3 to the power n is between minus 1 over 3 to the power n. So as n goes to infinity, this is goes to 0. This is goes to 0. So by the squeeze theorem, this is goes to 0. Just converges to 0. Easy ones. Yeah. He wants which of the following is false, not true. False. Okay. Yeah. By the way, you cannot have, yeah. I have to check this sequence. It will converge or diverge. Yeah, very clear. This sequence will, yeah, will diverge. Less than or equal to 1. So I can divide by square root of n. So as n goes to infinity, this goes to 0, this goes to 0. So this goes to 0 by sandwich theorem. This goes to 0 by sandwich theorem. By the squeeze theorem. So it diverges. All of these are correct. So it diverges. Actually, it's bounded. Sine is always bounded, and it's not monotonic because for the sine it will go up and down. So all of these are correct. So this is the wrong one. He wants the false. Square root n times ln. So I need to find the limit as n goes to infinity of this expression of this term, n term. How to do that? I can make it. You have what infinity times ln 1, which is 0. So infinity times 0. So I need to deal with this. So I make it ln 1 plus 1 over n to the power minus half. So now it's what? Now it's 0 over 0. Do L'Hopital's rule. I have what? 1 over 1 plus 1 over n times minus 1 over n square over minus half n is minus 3 over 2. So this I can rewrite as what? Yeah, this can go up minus 2 over 1 plus 1 over n times what? This will go up, it will be minus n to the power 3 over 2 over n square. I have this power is less than this, so this is goes to 0, and this is goes to minus 2. So the answer is 0. So let's convert this to 0. We know that if the power is less, the power of the numerator, the degree of the polynomial in the numerator is less than the degree of the denominator, then it will go to 0. Yeah, this one we did before. Yeah, it was the last one we did before that, and it will converge to 2. Yeah, no need to do it again. Yeah, it's converged to 2. This sequence, I need to be careful about this. I need to find the limit as n goes to infinity of this. Yeah, we need to rewrite this n plus 1 over 3n. It will be n over 3n plus 1 over 3n. Okay, to the power n. So that is what? Yeah, I can take 1 over 3 common factor, and the remaining is what? 1 plus 1 over n. All of this to the power n. Is it? Yeah, it's correct. So this is will be 1 over 3. Let me do it easily. That will be 1 over 3 to the power n. 1 plus 1 over n to the power n. 1 minus 1 over n. This, I think, goes to infinity. This goes to 0. This goes to e, and this goes to 1. So the answer is 0. It's convergence to 0. This sequence, 1 over n. Yeah, actually, you can do this. That will be 1 over n. This integral is easy one. Ln, it will be ln absolute value of x from 1 to n square. And that will be 1 over n times ln n square, which give me minus ln 1, which is 0. That give me what? 2 ln n over n. So now we need to find the limit of an as n goes to infinity. That will be the limit as n goes to infinity of 2 ln n over n, which is infinity over infinity. I can do L'Hopital's rule, and I will get the answer. It will be 2 over n over 1, and that will be 0. So let's compare just to 0. This one, 2 over 4. Yeah. What will be the formula? First, I need to find the formula. It's a little bit complicated formula. I have 2, 4, 8, 16. That 2 to the power 1, 2 to the power 2, 2 to the power 3. I'm considering n greater than or equal to 1. So it will be 2 to the power n. I have 1, 3, 5, 7, which is the odd numbers, which is 2n minus 1. So at 1, it's At n equal 1, it's 1. At n equal 2, it's 3, and so on. Okay. Now over. Look at this one. This is 4, which is 2 square, 2 cube, 2 to the power 4, 2 to the power 5. I'm talking about the first number. So this will be 2 to the power n plus 1. I'm starting with n, that will be 2 square. This is 4, 7, 10, 13. At n equal 1, 23, n plus 1. Yeah, at n equal 1, it's 4. At n equal 2, it's 7, and so on. So now this one is what? It will be 2n minus 1 over 2, 3n plus 1. So I need to find the limit of an as n goes to infinity, which means the limit as n goes to infinity of 2n minus 1 over 2, 3n plus 1. Same degree, so I have just the coefficient 2 over 6, which is 1 over 3. That will be the answer. Yes. This one, yeah, it's an easy one. Just I take the limit inside. 3 sine inverse square root 3n minus 1 over 4n plus 1. So that will be 3 sine inverse of the square root of this limit. Since sine inverse and square root, they are continuous in their domain. This limit will be 3 sine inverse. What is that? 3 square root of 3 over square root of 4, which is 2. What is sine inverse of square root of pi over 3? Square root 3 over 2. That will be pi over 3, which is 60. Yeah, that give me pi, which is the answer. Okay, the sequence is convergent. No need to prove it's monotonically bounded. That's it. So that means the limit, and it's convergent to L. That means the limit of an as n goes to infinity is equal to L. And the same thing, the limit as n goes to infinity of any an plus 1, an plus 2, anything like that, that will be L. So apply the limit for this one. You have what? L equal 8 plus 2L. So square both sides, you have L squared is 8 plus 2L. So I have L squared minus 2L minus 8 equals 0. Now I need to solve this. So I have L minus 4, L plus 2 equals 0. So I have L equal 4 or L equal minus 2. This is impossible since when if I substitute, I'm getting minus 2 equal 2, which is wrong. So L equal 4. That's the only solution. I have L equal. Let n equal this. Then the sequence is. So let me first rewrite this. I know how to find the integral. That will be ln of t from n to n plus 1. So I have ln n plus 1 minus ln n, which is ln n plus 1 over n. All are positive, so no need to worry about the absolute value. So what is the limit now of an as n goes to infinity? That will be the limit as n goes to infinity of ln n plus 1 over n. I can take the limit inside. So I have ln this limit. Same degree. So I'm getting only the coefficient. So it's ln 1, which is 0. So it's convergent to 0. This one is an easy one. That will be ln n over n minus 1. So if I want to find the limit as n goes to infinity of an, I can take the limit inside, like what we did in the previous one. Let me do it in details. That will be then limit n goes to infinity, n over n minus 1. That will be ln 1, which is 0. So it's converges to 0. Same idea. Now this is ln, yeah, an is what? Ln 2n squared plus 1 over n squared plus 2. So the limit as n goes to infinity of an will be the limit as n goes to infinity of ln this. So I can take the limit inside, I have what? 2n squared plus 1 over n squared plus 2. That limit is what? Same degree, so it will end 2. So this is the answer. Secant inverse. This. Yeah. What will happen with this secant inverse? Okay. Yeah, I need to find the limit as n goes to infinity of secant inverse n sine 2 over n. Yeah, let me do this side. So I let t equal 2 over n. So this limit will be limit t goes to 0. N will be 2 over t and have sine t. So it will be 2. It will be the limit at t goes to 0 of 2 sine t over t, which is 2 times 1, which is 2. So this limit is 2. So take the limit inside. So that will be secant inverse, the limit of this, which is we just did, and that will be secant inverse of 2. What is secant inverse of 2? It will be pi over 3. Yeah. Because I know cosine inverse of 2. Cosine inverse of pi. Cosine inverse of pi over 3. Cosine of pi over 3 is half. So secant pi over 3 is 2. This one, he says it converges to what? So I would say it converges to L. So I know that limit of an equal limit of an plus 1. Assume converges to L is equal to L. So I have applied this, the limit to both sides. I have L equal square root 5L. Square both sides. I have L square equal 5L. So I have L square minus 5L is equal to 0. So that means L minus 5 equal to 0. So L equals 0 or L equal 5. I have the answer 5. So this is actually cannot be 0 because I know it will be a bigger number. I have 1, then I have square root of 5, then I have square root of 5. Yeah, it will be greater than 0 for sure. This sequence greater than 0. So it cannot be 0. So yeah. This sequence, yeah, I think it's an easy one. I have the limit. Just I need to take the limit inside. N goes to infinity. Cosine n pi over 2n plus 5. Take the limit inside. That will be cosine limit n goes to infinity. N pi over 2n plus 5. That will be cosine. This limit is what? Pi over 2, which is 0. So it converges to 0. Yeah. N sine 2 over n. I did it. Yeah, actually, we did it here. So it's very clear it's 2 as a limit. No need to do it again. Converges to 2. This sequence, yeah, if you look at it, you're getting what? This is 4, 6, 8, 10. So that I want to write the sequence. 4, 6, 8, it will be 2 times 1, 2 times, not 2 times 1. It will be 2 times what? Yeah. It will be 2n. Starting from 1. No, it will be 2n plus 1. Yeah. Or I have 2 times 2, 2 times 3, 2 times 4. So if it's starting from n greater than or equal to 1, so we have 2 plus 1. There I have what would n equal 1. That will be 2 plus 3n. Because this is 2 plus 3. This is 2 plus 3 times 2. This is 2 plus 3 times 3, and so on. So it's 2 plus 3n. So it is the limit of an as n goes to infinity. It will be the limit as n goes to infinity of 2n plus 2 over 3n plus 2. Same degree, so the answer is 2 over 3, and that is the answer. Yeah, that's a difficult one. Okay. Yeah, this one, I can rewrite it. An half ln n square plus 1 minus ln 2n plus 1. That will be ln square root n square plus 1, because this is go as a power, minus ln 2n plus 1, which is ln square root n square plus 1 over 2n plus 1. So what is the limit as n goes to infinity of an? It will be the limit of this, ln. Yeah, I need to find this limit. When I take the limit inside. Yeah, this is, I need to deal with the square root. So I take n square common factor. I have 1 plus 1 over n square over this. Since it goes to infinity, no need for the absolute value. So I take n out, then square root 1 plus 1 over n over 2n. And also I can take n here out. You have n 2 plus 1 over n. So this n cancels, so I have 1 over 2. So if I take the limit inside, I have limit, then limit n goes to infinity, square root of this over 2n plus 1, which I know it's half, which I can write it minus ln 2, which is the answer. Okay, now this sequence, yeah, I need to find this limit. N goes to infinity. 1 minus 2 over 5n to the power 5n. Okay. Yeah, if you remember, either I do it with the power and using Lobiter's rule, or I can use these formulas. Sometimes they will help. Remember the formulas which is with it. Yes. So I have this formula. 1 plus x over n to the power n is e to the power x. And this is actually what I will do. I'll try to write it in this format, and then I will apply the formula. Let me have the formula here. Limit n goes to infinity. 1 plus x over n to the power n. It's e to the power x. So we need to write this. Now I let t equal 5n. Then I have what? This limit. 1 minus 2 over 5n to the power 5n will be what? Limit. If n goes to infinity, then t goes to infinity. 1 minus 2 over t to the power t. So now it's written in this format where x is minus 2. I can just to see it. I can say this is 1 plus minus 2 over t all to the power t. So if this format, it will be, yeah, the same, but with x equal minus 2. So that will be e to the power minus 2. It's convergence, and its limit is minus e to the power minus 2. Okay. Determine whether each of the sequences convergent or divergent. Yeah, we need to be careful. First, I need to rewrite this. So an will be what? I have 1 times 2 times 3 times 4. That will be n. I have 3, so it will be 1 plus 2. This is 1 plus 3. Not, no, this is 2 plus 1, because I need it with n greater than or equal to 1. Huh? This is 2 plus 2. I'm talking about 4, about 3. This one will be 2 plus 3. So I have 2 plus n. And this is what the denominator will be n plus 1. Yeah, at n equal 1, it's 2. At n equal 2 is 3, and so on. So now I need to find the limit of an as n goes to infinity. Which will be the limit as n goes to infinity of n 2 plus n over n plus 1. This degree is more than this, so this will be infinity. So the sequence diverges. The degree of the numerator is greater than the degree of the denominator, so it will go to infinity. This sequence, whose in term is this? Okay. Yeah, we can use the squeeze theorem, I think, easily here. Let's get between -1 and 1. So now divide by n. You have -1 over n. Less than 1 over n. This is goes to 0, as n goes to infinity. This is goes to 0. So it means this by the squeeze theorem goes to 0. So the limit, so the sequence an converges, and its limit is 0. Okay, determine whether the sequence converges or diverges. If it converges, find the limit. Okay, so I need to find the limit as n goes to infinity to see I'm getting a value or not. 2n plus 5 over square root 1 plus 2n plus 9n square. So I need to deal with this square root. Take n common factor. I have 2 plus 5 over n over. I have square root. You can take n square common factor. I have 9 plus 2 over n plus 1 over n square. And n goes to infinity, so n is positive, so no need to worry about the absolute value. So I have what? N 2 plus 5 over n. I have here n square root 9 plus 2 over n plus 1 over n square. This is cancelled. So that will be 2. And here I have square root of 9, which is 2 over 3. So an converges, and its limit is 2 over 3. Okay, I think we have just 3 problems to go. Okay. Now, let me deal with this one. Yeah, I need to write it. Find the limit of the sequence that converge, make sure just my answer. Okay. So this one, if I want to write it, I have 1, this is 1 over 1. So it's 1, 2, 3, 4. Which is this one. I can write it 1 over 1 square minus 0 square. Yeah. So an will be what? In the numerator, it's n. I have n greater than or equal to 1. I'm dealing with this. Over. This one at n equal 1, that will be n square minus n minus 1 square. Because at n equal 1, it will be 1 square minus 0 square. At n equal 2, it will be 2 square minus 1 square, and so on. That will be my sequence, which is what? Which is n over n square minus n square minus 2n plus 1. So that will be n over 2n minus 1. Now, if we need to find the limit as n goes to infinity of an, I need to find the limit as n goes to infinity of n over 2n minus 1, and that same degree, so it will be half. So this sequence converges, and its limit is half. Its limit is half. Okay. Then n plus 1 over square root of n. How to do that? I'll do the limit an, where n goes to infinity. That will be the limit as n goes to infinity. Then n plus 1 over square root of n. If we apply the infinity, you have infinity over infinity. So I use L'Hopital's rule. Let me see what will happen. I have 1 over n plus 1 times 1, which is no need to worry about. This is, actually I can say n to the power half, so that will be half n is minus half. So I have what? This is will be yeah, we can do it square root of n. So I have 2 square root of n over n plus 1, which is the degree of the numerator is less than the degree of the denominator, so this limit will be 0. So an converges and its limit is 0. Okay. I think this is the last one. It's, I think, easy to do. Now we need to find the limit as n goes to infinity. Yeah, by the way, what is an? An is 2n plus sine n over n, which is 2 plus sine n over n, which is 2 plus sine n over n. Yeah, let me do the limit of sine n over n. How to find this? This is will be 0. Why? Because sine n is between -1 and 1, and sine n over n is between -1 over n and 1 over n. This goes to 0. This goes to 0 as n goes to infinity. So this goes to 0 by the squeeze theorem. So this limit equal to 0. That implies the limit as n goes to infinity of an will be 2 plus 0, which is 2. So an converges and its limit is 2. I think that's it. Yeah. So let me stop the recording. I think we did good number of questions for this. Thank you for this section. Thank you.